Hi friends, welcome back to new session. In this session, we will discuss about the vector diagram of an alternator and formulae from that vector diagram. Very important topic for GATE examination point of view. Okay, so let us see vector diagram of an alternator. Yeah. We know in synchronous machine, generally we will be placing armature winding on the stator. So let me take armature winding, which is this is stator. But armature winding also generally it will be in a star connection. Will be in a star connection. Now we will be placing field winding on the rotor. To this field winding, we are giving DC supply for excitation. So this field winding is placed on the rotor, right? Armature is placed on the stator, right? Now let us see. Let me connect some load here. Load. You close switch. Now let us see. See guys, because of giving DC supply to the field winding, that means because of excitation, main flux will be produced, and rate of change of flux linkage will be there in alternator. Thereby, EMF will be induced here. From this, current IA current is coming, and here I phase, I can say nothing but IL value, and I can take this voltage as load voltage V. See, since it is star connection, in star connection, armature current, phase current, load current, both are same only. Every time there is no need to repeat. Just remember, in alternator, since armature winding is star connection, IA equal to I phase equals to IL. Okay, and this EMF, this is about generated EMF. If you want to explain vector diagram of an alternator, for drawing vector diagram of an alternator, we need one equation. From that equation only we can draw vector diagram of an alternator. So see, whatever EMF induced in alternator, that E, ideally it is equal to V, but practically so many drops will be there. What are those drops? Whenever armature current is flowing to this armature winding will be having some resistance RA. So whenever this IA is flowing to the armature winding, IA RA drop will come into picture, and because of leakage flux will be having some drop. Let me show the drop with IA XL. Because of armature reaction will be having some drop. So let me show with IA XA. This I already told whenever we discussed causes for drop in terminal voltage topic. There I just told this one. E equal to V plus IARA plus JIA XL plus JIA XA. Now from this tell me E equals to V plus IARA plus, if I take JIA common, this is about XL plus XA. You know, V plus IARA plus JIA, XL plus XA equals what? XS. XS means XL means leakage reactance. XA means armature reactance. XS means synchronous reactance. So from this once again, if V plus, if I take IA common, becomes RA plus JXS. So V plus IA into RA plus JXS gives you ZS. ZS means what? Synchronous impedance. This nomenclature I'll give at last. Armature resistance RA, XS means synchronous reactance, ZS means synchronous impedance. Okay, this is nothing but equation. From this equation, let me draw vector diagram of an alternator. Whenever DC supply is given to the field winding, so flux will be produced. That can be called as main flux. You can call it as pi m. Pi m is the main flux, right? Main flux. main flux, because of DC supply to the field winding, because of excitation, whatever the flux we got, that flux can be called as main flux. Okay, and because of this main flux only, you got EMF here in armature winding. So this EMF lags flux pi m by 90 degrees. 90 degrees. Is it clear? Right. Now, yes. Because corresponding to this pi m, we are getting this EMF. That's why these two vectors are displaced by 90 degrees. To be frank, E lags flux by 90 degrees. Next, here, after EMF is induced in the armature winding, then we are getting load. Then we are getting voltage at the load. To be frank, V lags E by an angle delta. Okay. So this is what E I can say. V lags E by an angle delta. Okay, this is what I can say. V vector lags E by an angle how much? Delta. This delta can be called as load angle. What is that? Load angle. Now after this, okay. Now let us discuss vector diagram for lag load. Whenever you are drawing vector diagram for lag loads, you know load current means IL equal to I phase equal to IA. This IA lags V. Is it clear? IA lags V. So I am just drawing vector diagram for lag loads. That's why IA lags V by an angle how much? Pi. By an angle how much? Pi. This pi is nothing but power factor angle of alternator. Delta means load angle. That is the angle between E and V. If you want, I can write here. Okay. Delta means, okay, it is the angle between V and E. Here, just remember, guys. To be frank, we will take V as reference. Always load voltage we are taking reference in alternator. Now tell me, I told you V lags E by an angle delta. That is what indirectly E leads V by delta. So delta is the angle between V and E. Okay, this delta is nothing but okay. I can say since our reference vector is V, your E leads V. That's why delta is a positive in alternator. In alternator point of view, it is positive. And what is the name I had given for this delta? Load angle or power angle. Okay, right. This is what I can say delta. And what about pi? Pi is the angle between, okay, V and IA. Observe guys clearly. Here V is reference. See, I'm just explaining here lag loads, right? Therefore, IA lags V by an angle of pi. Since IA lagging V reference vector, so for lag loads you should take minus pi. For lead load, IA leads V, no. At that time we should take plus pi. So I can write here pi is angle between V and IA, okay, which is equal to, I can say, minus pi for lag loads, plus pi for lead loads. And what is the name I can give for this pi? So I told you now, pi means what? Load power factor angle of an alternator. Load power factor angle of an alternator. I can say power factor angle of load power factor angle of an alternator. Right? Now please tell me, if you want to write this vector by using that equation, E equal to what I said, V. V is here. To this V, what we have to add? IARE. IARE drop will be in phase with IA vector. This is what IA. So I can draw in phase vector means I can draw like this. This is what IARA. And what about JIAXL? it is making 90 degrees with your IA, nothing but with this vector, nothing but with this vector, because these two are parallel, no? Therefore, let me draw 90 degrees, okay? This is what I can say. JIA XL, JIA XL, JIA XL. Now what about this one, JIA XA? This is also 90 degrees with your IA, nothing but 90 degrees with your IARA, or in phase with your IA XL. This is what I can say, IA, JIA XA, JIA XA, JIA XA. You please tell me, what about this total value? IAXL plus JIAXA gives you how much? Right, tell me. XL plus XL is XS. JIAXS is the total drop item. Is it clear? Now, angle between, guys, observe guys clearly. Angle between E and IA is nothing but psi. Psi means what? I can write here. Psi is the angle between E and IA. Psi is the angle between E and IA. This psi can be called as internal power factor angle. Internal power factor angle. Internal power factor angle. Internal power factor angle. Is it clear? Now please tell me, IARA plus JIAXS gives you what? IAZS, no? So this is what IARA, this is what I can say IAXS. So total from here to here, observe clearly, from here to here, this product from IARA plus JIAXS gives what? IAZS. 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 Is it clear? Right. Now, on one more thing. So just do one thing, just note down up to this. Read it. Now, see one more thing. You know, because of armature current IA, we will get a armature flux pi A. This IA and pi A will be in phase. If you want resultant flux to this pi M, let me add this pi A. Let me add this pi A here. This is what I can say, pi A. Or to this pi A, let me add this pi M. This pi M. This is pi M. So that resultant gives you what? This resultant vector gives you. Result vector gives you what? Pi R. Pi R. Pi R. Pi R. Okay. Corresponding to this pi R, you will get ER. What is that? ER. So angle between pi R and ER is equals to 90 degrees. Just like pi M is, EMF, E is corresponding to pi M. Pi M and E displays 90 degrees. Similarly, pi R correspondingly we will get ER. This pi R and ER is displaced by 90 degrees electrical. So this is what I can say pi R. If you want ER equal to V plus IARA plus JIAXL. Don't add IAXA here. Don't add IAXA here. Because here effect of armature flux and main flux gives you pi R. That means armature reaction we already considered, no? Armature reaction is what? Effect of armature flux and main flux is called armature reaction. Effect of pi A and pi M, that gives you pi R. So corresponding to pi R, we are drawing resultant vector ER. Therefore, in this ER, there is no need to include armature reaction drop. So please don't add IA XA here. This is what I can say ER. So please indicate here V plus IARA plus IAXL up to this only. This gives you ER. Okay. Angle between this pi R and pi A, sorry, pi R and ER is equal to how much? 90 degrees. Don't confuse. This is what ER. I can write here. This is what I can say ER. Is it clear? Yes? Right. So now this ER can be called as resultant voltage, resultant EMF or resultant voltage, or air gap voltage. Why? This ER is corresponding to pi R. Pi R is nothing but what? Resultant flux, or I can say resultant flux, or I can say air gap flux. So this is what pi R here. Is it clear? Yes. Now see here. Now let me just tell me what one. Yeah. You just tell me from this. I need some formulae. I will explain here formulas. Anyway, once again I will tabulate all those formulas. It will be easy for you to remember. First, tell me alternator point of view. I am saying. Okay. Okay. Anyway, I will draw here only. Observe clearly. I will write formulas here only. First one, alternator. Here I can write synchronous motor. Right. First formula. Very basic formula. Tell me what is the basic formula for alternator? E equal to, what is that? E equal to V plus IA into ZS. Very basic formula, everybody knows that. E equal to V plus IA ZS, everybody knows that. Okay. So, but I need formula in terms of, angles, which is the reference vector for us here? V at 0. Tell me E. I told you already, angle between V and E is nothing but delta. That delta is a positive in alternator because E is leading V by delta angle. Therefore, I can write here plus delta. And what about IA? V angle between reference vector V and IA nothing but pi. This pi, plus pi is for lead, minus pi for lag. So I can write here plus or minus pi. Here plus pi is for lead, minus pi is for lag. Very good. Now what about ZS? ZS at an angle of theta S. Because see, theta is ZS equals generally, synchronous impedance equals to RA plus JXS. From this, theta is equals to tan inverse of XS by RA. Here theta S means what? Theta is nomenclature. Impedance angle of an alternator. Impedance angle of an alternator. So theta is equal to how much? Tan inverse of x by RA. Theta s can be called as impedance angle of an alternator. Is it clear? Right. Now, can you please tell me? I need for synchronous motor basic formula. I need synchronous motor basic formula. See, in motor point of view, this load becomes the source. Load becomes the source voltage. Previously, I wrote E equal to V plus IAZS. Now nothing but V equal to E plus IAZS. Everybody knows that. So let me write the formula here. Formula number 1 under synchronous motor. V equal to E plus IA into ZS. See, nomenclature anyway I'll give at last, but anyway just listen. Here E means, what is the name for this E? Generated EMF. Can you please tell me what is the other name for E? Suppose if load is not there, if switch is open, there is no current, no drop. Clear? If switch is open, this E can be called as no load voltage. So what is the name for E? Generated voltage, no load voltage. Okay. Because of this excitation to the field winding, I got this EMF E. That's why this EMF can be called as excitation EMF also. So please remember, I'm explaining here only. At last, I'll write names directly. E means no load voltage, generated EMF, excitation EMF, induced EMF, like so many names are there. What is the name for E in motor? In motor, generator action takes place. Because of that generator action, EMF will be induced. That EMF can be called as back EMF or excitation EMF. So synchronous motor E can be called as back EMF or excitation EMF. And what about V? V means load voltage. V means what? Load voltage in case of your alternator, or terminal voltage. In case of synchronous motor, V means what? Supply voltage, line voltage. Next, IA, everybody knows that armature current. ZS means what? I had given here, impedance angle of alternator. Synchronous motor, ZS means what? Impedance angle of synchronous motor. Now tell me, in case of synchronous motor, I think this one completed, no? Just note down first this. Right. See? So in case of synchronous motor, just tell me in terms of angles I need formula. For that, what we are doing is for synchronous motor. This is for, I'm saying, synchronous motor point of view. This is for this is for alternator point of view. For alternator, you know. I'm saying synchronous motor point of view. Just listen carefully. Synchronous motor point of view. This is supply voltage V, which is reference. Motor point of view, you please call V as supply voltage. There is no need to draw once again. In place of load, you'll get supply, that's it. So V can be taken as supply voltage or line voltage. So after supply voltage, then your back EMF will come into picture. So this is what I can say, back EMF E. Angle between V and E, just like previously in case of alternator, E and V are discussed delta, here also delta only. This delta can be called as what? I told you in an alternator, load angle. Here also load angle, or sometimes we can call it as a torque angle also. Load angle, sometimes we can call approximately delta as a torque angle also. Okay. Next, right. Now suppose if 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 synchronous motor is operating at lagging power factor, that means Ia lags V by an angle of something. What is that angle? Pi. And what is the angle between Ia and E? Phi. So please tell me, suppose you tell me guys, for lead loads, you tell me, for lead loads, how, like this, what your V reference, okay, and EMF E lags by an angle of delta. Leading, synchronous motor operating leading power factor. So I can take Ia leads V. What about this angle? Phi. Angle between Ia and E. How much? Phi. Is it clear? Now tell me. What is the basic formula you can write? Since V is reference, we can take here V at 0. And what is the angle between E and V? Delta. E and V, delta. So tell me, I have to write plus delta or minus delta? You should write delta as a negative. Why? Your E lags V by an angle of delta. In case of lag or lead also, E lags V by an angle of delta. So you should take minus delta. Don't confuse. In case of alternator, you have taken plus delta because E is leading V. That's why you have taken a plus delta. Now you should take a minus delta. Next, Ia at an angle of. See, previously for alternator also plus or minus pi wrote, no? Plus pi is for lead, minus pi is for lag. This won't change. This will be same only. You should write simply plus or minus pi. For lead loads, you should take plus pi. For lag loads, you should take minus pi. I can write plus pi when the synchronous motor is operating at leading power factor. Minus pi when synchronous motor operating at lagging power factor. ZS at an angle of what? An angle of theta, yes, theta, yes. Is it clear? Right. Now, what about ZS? ZS is equals to, I told you, RA plus J XS. From this, theta is equals to how much? Tan inverse of, as usual, XS by RA. Theta S means what? Impedance angle of synchronous motor. Okay, this is formula number 1. Next, formula number 2. See guys, formula number 2. If RA is negligible, at that time, in place of ZS, what will write? In place of ZS, if R is negligible, what is the magnitude? XS. In place of theta is how much? Tan inverse of XS by, RA value 0, tan inverse of infinity, how much? 90 degrees. So at that time, how this formula becomes? E at an angle of plus delta, I'm just writing formula number 2 for alternator, equals to V at 0, okay, plus Ia at an angle of plus or minus pi into XS at an angle of 90 degrees. In place of ZS, I wrote XS. In place of theta S, I wrote 90 degrees. That's it. This is a very simple modification, right? Now tell me why I wrote this formula means previous gate point of questions, maximum questions they'll give by neglecting armature resistance. So at that time you should use this formula. Okay, simply by replace ZS with XS, replace theta S with 90 degrees. Now what about formula number 2 under synchronous motor? As usual, if RA is 0, just write in place ZS, XS, in place theta S, how much? 90 degrees. So here also same thing. V at 0 is equals to E at an angle of minus delta plus I at an angle of plus or minus pi, xs at an angle of how much? 90 degrees. This is what I can say formula number, 2. Next, tell me formula number 3. Formula number 3 for alternator. Can you please tell me, from alternator means you have to see this diagram, right? Tell me what is the relation between psi, delta and pi. This is for lag loads. So I can write simply for lag load, tell me here what is the relation between psi, delta and pi? Psi equals delta plus pi. Psi equals to delta plus pi. This is for lag loads. Suppose guys for lead load, I am asking lead loads for alternator only. Same, simply write E vector, V vector only. This is what E value. I am explaining alternator. E, this is V. V is reference. Okay, angle between E and V. How much? Delta, as we know. Leading means load current IA leads voltage. Here it will come. This is what IA. Now angle between V and IA nothing but what? Pi. Between E and IA nothing but what? Psi. Tell me relation. Delta equal to psi plus pi. Psi equals to delta minus pi. See, it's very simple. For alternator is these two things I am saying. For synchronous motor, these two diagrams. Now tell me. So psi equals to delta plus pi for lag loads. Psi equals delta minus pi for lead loads. So please write here. Psi equals to delta plus pi for lag loads minus psi equals delta minus pi for lead loads. Therefore, I can write simply psi equals delta plus or minus pi. I can write where plus is for lag, minus is for lead. Psi equals delta plus or minus pi, where plus is for lag, minus is for lead. Now tell me formula number 3 for synchronous motor. See, use synchronous motor means you should see this diagram. Tell me lag loads. So delta equals to psi plus pi. From this psi equals to delta minus pi. Here lead loads. Psi equals to delta plus pi. So observe carefully. For synchronous motor, lag loads means psi equals delta minus pi. Lead loads means psi equals delta plus pi. So I can write simply here psi equals to delta minus pi is for lag. Okay. Plus pi is for lead. So psi equals delta minus or plus pi, where minus is for lag, plus is for lead. So please remember, if you want to remember forever, see for alternator, psi equals delta plus or minus pi, plus for lag, minus for lead. Synchronous motor, psi equals delta minus or plus pi, minus for lag, plus for lead. Like that, please try to remember. It will be easy for you. Okay. You just note down up to this, then I'll go for formula number 4, please. Right. Now, please try to see. We'll have one more formula. See, let us take this one once again. So this is what we said. It's nothing but pi m. I'm just explaining this vector diagram once again for alternator. This for alternator, no? Alternator, to be frank, lag load. So same thing I'm just taking here once again. Alternator lag pi m. This is what I can say E vector, right? And this is what I can say V, because in alternator E V lag E, finding how much delta. And since it is lag load, IA lags V. Yeah, IA lags V. Finding how much? Pi. Now just see E equals to V plus IARA. So let me add IARA is this one. IARA drop plus this total I'm saying. Total how much? JIA excess. JIA excess. This portion. This is what I can say your E value. Same thing only. I just done 1 second. That's it. Huh? Now please. Here I'm asking a simple question. Yeah. If you draw a vertical line here, extend this to this portion. Tell me this value I'm asking. Okay. And similarly, first tell me this value. After that we'll see. And what of this value? This value it is clearly visible, no? IARE. So I can write here IARE. So this value you know JIA excess. In addition to this, I need here one more value. I need this value also. This value you should know. This value you should know. For that, what you have to do? For this triangle, this opposite side, hypotenuse, adjacent side. If you want adjacent side, apply cos phi formula. Cos phi is equals to adjacent side. This value. Example, let me take this one as x. X by hypotenuse v. X is equals to v cos phi. So this is what I can say. V cos phi. Now what about this value? If you want this value, nothing but this value, in sin pi formula we have to apply. Sin pi is equals to opposite y by hypotenuse v. Y equal to v sin pi. So here we can write v sin pi. So after this, you tell me now, if you want E value, E equal to square root of what? E equal to square root of this. E equal to square root of this side square plus this side square. This side means what? V cos phi plus IARA whole square plus V sin pi plus IA excess whole square. Is it clear? Very simple. E equal to square root of this side square plus this side square. This side means V cos plus IARA. From here to here side means V sin pi plus IA excess. So this is the vector diagram for lag, no? It's a vector diagram for lag load. So let me write the formula here. Formula number 4. E equal to square root of V cos phi plus IARA whole square plus V sin pi plus IA excess whole square. E equals square root of V cos phi plus IA RA whole square plus V sin phi plus IA access whole square. See guys, this formula is for lag loads. If you do like this for lead loads, in place of this plus, you'll get minus. So simply write here plus or minus phi, where plus is for lag loads, minus is for lead loads. Very simple. Now what about same formula for synchronous motor? Synchronous motor, if you want back EMF or exercise EMF, that I can write like this. E equal to, observe clearly, square root of V cos phi, this plus becomes minus. Square root of V cos phi minus IA RA whole square plus square root of V cos phi minus IA RA whole square plus V sin pi plus or minus becomes minus or plus. Minus or plus IA access whole square. Observe guys clearly. Square root of V cos phi minus IA RA whole square plus V sin pi minus or plus IA access whole square. Where minus is for lag, plus is for lead. So derivation is not necessary. Just remember directly, because gate point of view, you should remember formulae and you have to do 2 marks questions. Okay. So just write always side by side, so that you can remember forever. See this formula: E equals square root of V cos plus IA RA whole square plus V sin plus or minus IA access whole square for alternator, where plus is for lag, minus for lead. For synchronous motor, E equals square root of V cos phi minus IA RA whole square plus V sin pi minus or plus IA access whole square, where minus is for lag, plus is for lead. Okay, just note down this and just add these 2 formulas. Right. Observe guys here. This basic formula, whatever I told, this formula number 1, this is valid for cylindrical pole alternator plus salient pole alternator. Nothing but both. So, and this synchronous motor formula also, this is valid for, you can write here. I think there is no need to confuse. I'll write here. This is applicable for cylindrical synchronous motor and silent pole synchronous motor. Okay. So this formula number 1, cylindrical pole synchronous motor and salient pole synchronous motor. Nothing but I can say both. This can be called as both alternators. This I can say both motor. Similarly guys, this formula also applicable for both alternators. Nothing but it is applicable for cylindrical pole alternator and silent pole alternator. This formula also applicable for both cylindrical pole synchronous motor and silent pole synchronous motor. This formula also applicable for both cylindrical pole synchronous motor, cylindrical pole synchronous generator and silent pole synchronous generator. This formula applicable for both cylindrical pole synchronous motor and silent pole synchronous motor. So once again both. This formula also applicable for both motors. Formula number 4 is there, no? This formula is only valid for cylindrical pole alternator. Similarly, this formula number 4, this is also valid for cylindrical pole synchronous motor. Okay, that means you should know formula for salient pole alternator here, silent pole synchronous motor here. So that formula number 5 I am just giving here. Okay, this is for alternator and this is for synchronous motor. Formula number 5. So for cylindrical pole alternator, I had given you formula for E. I am just giving formula E value for salient pole alternator. What is that formula? E equal to V cos delta. E equal to V cos delta plus IQRA plus or minus IDXD. So E equal to V cos delta plus IQRA plus or minus IDXD. You might have seen in two reaction theory, by using two reaction theory, I told you wherever D, Q words are there, those formulas are valid for silent pole machine. Okay, just try to see that two reaction theory topic. E equal to V cos delta plus IQRA plus or minus IDXD, where plus is for lag, minus is for lead. So tell me this formula for silent pole synchronous motor. So please try to see, always try to compare and you can study, you can remember forever. E equal to V cos delta minus IQRA. This plus becomes minus IQRA minus R plus IDXD. E equal to V cos delta minus IQRA minus R plus IDXD, where minus is for lag, plus is for lead. Okay. In this, ID means what? Direct axis component of armature current. IQ means what? Quadrature axis component of armature current. XD means what? Direct axis synchronous reactance. What about XQ means what? XQ is not there here. I'll show you. XQ means what? Quadrature axis synchronous reactance. Okay. So the nomenclature anyway, I'll tell at last. Before that, please see. E equal to V cos delta plus IQRA plus or minus IDXD. E equal to V cos delta minus IQRA minus R plus IDXD. Minus is for lag, plus is for lead. Where ID is equals to IA sin psi. IQ equal to IA cos psi. These are the same. ID equal to IA sin psi. IQ equal to IA cos psi. Okay. Next, last formula, sixth formula. So this formula and this formula 5 and 6 we will get from vector diagram of silent pole machine. So it's not necessary for us directly. You have to remember formula because derivation is not important for GATE point of view. Please remember formulas directly so that you can solve questions. Okay. See, I'll tell you, if you remember this tabular column, only very simple formula 1, 2, 3, 4, 5 and 6. If you remember this sixth formula, in synchronous machine, 2 marks point of view GATE questions, whatever is there, okay, out of 100% I see, maximum questions we can solve. So it will cover entire, entire two, not entire I'm saying. So 2 marks questions means generally will be getting from a EMF equation and a power flow equation is there. Except that if you see remaining all cases, maximum questions we can solve by using this 6 formula. That's why I'm asking you to remember this 6 formulas. Very important. I'm saying this tabular column is very important. Very important. Very important. Very important. Very important. Okay. So gate point of view, maximum 2 marks can be solved. You will come to know because after completion of this tabular column, we'll start discussing previous questions. There you can understand. Maximum question you can get answers. Okay. So formula number 6 for silent pole alternator, tan psi is equals to V sin phi plus or minus Ia x cube by V cos phi plus Ia Ra. V cos phi plus Ia Ra. Tan psi equals V sin phi plus or minus Ia x cube by V cos phi plus Ia Ra. Where plus is for lag, minus is for lead. Now here sixth formula. Tan psi is equals to V sin phi minus or plus Ia x cube by V cos phi minus Ia Ra. Is it clear? Tan psi equals to V sin phi minus or plus Ia x cube by V cos phi minus Ia Ra, where minus is for lag, plus is for lead. Okay, you do one thing. Here in this formula, if you see, plus is for lag, comma, UPF also. Here, minus is for lag, plus is for lead, comma, UPF also. Because sometimes it will be useful. Remaining case, if you see in this diagram, if a unity power factor means what? Cos pi 1, sin pi 0. This becomes 0, no? So plus or minus, I don't have any effect. It will become plus only. But here you will be having some confusion will be there. So that's why I indicate here lag, plus is for lag, comma UPF, minus is for lag here in case of synchronous motor, plus is for lead, comma UPF. Okay. So this formula number 5 is for what? Salient pole alternator. Formula number 5 here. Salient pole synchronous motor. Synchronous motor. Here formula number 6 once again. Salient pole alternator. This formula is applicable for salient pole synchronous motor. Synchronous motor. Once again I am saying this tabular column which consists 6 formulas are very important. Because I am just repeating once again, in maximum people will be having some problem in solving synchronous machine gate questions. So very simple. Synchronous machine gate questions generally 2 marks point of view will be getting from EMF equation of an alternator and output power flow equations of alternator, nothing but P equal to EV by X sin delta. EMF equation is E equals 4.44 kp kd pi ft phase. That is okay. Everybody can do it. Except that remaining maximum questions, maximum 2 marks questions can be solved by remembering these 6 formulas. That's why please write these formulas clearly without any mistake, and please try to remember these formulas so that you can solve maximum questions. And one more thing. So in the next session, I'll continue this session. Okay. In the next session also, I'll continue the same topic here. Nothing but I'll give nomenclature for alternator. I'll give nomenclature for synchronous motor, and we'll start discussing previous questions. Okay. By using this formula, we can solve maximum questions that you only will come to know. Okay. So please remember these formulas. Very important. So let me repeat once again. E at delta equals to V at 0 plus Ia plus or minus pi into Zs at an angle of theta s. Here V equal to E plus Ia Zs only. E means, if you want I can write here. Delta, I already told, delta positive for alternator, delta negative for synchronous motor. That don't forget. And here this by neglecting Ra equal to 0, in place of Zs you have to write Xs. In place of theta s you have to write 90 degrees. And psi equals delta plus or minus phi, plus is for lag, minus for lead. For synchronous motor point of view, psi equals delta minus or plus phi, minus is for lag, plus is for lead. You may get out. So what about UPF, sir? What is there here? Cos pi 1, pi value 0. Delta minus r plus 0. So psi equals delta only, no. So I don't have any effect, right? Leave it. Now what about E equal to square root of V cos plus IRA whole square plus V sin pi plus or minus IA whole square, plus is for lag, minus for lead. E equal to V cos minus IRA whole square plus V sin pi minus R plus IA whole square, minus is for lag, plus is for lead. And here, these four formulas are valid for both machines, nothing but alternator point of view, applicable for cylindrical pole alternator, silent pole alternator. These four formulas are applicable for cylindrical pole synchronous motor and silent pole synchronous motor, both. Whereas formula number 5 and 6 is applicable only for silent pole alternator, here silent pole synchronous motor. What is that? E equal to V cos delta plus IQ RA plus or minus ID XD, ID equals IA sin psi, IQ IA cos psi. Here E equal to V cos delta minus IQ RA minus R plus ID XD, minus for lag, plus is for lead. Here tan psi formula, V sin pi plus or minus IA XQ by V cos plus IA RA, plus is for lag, UPF. Tan psi equals V sin pi minus R plus IA XQ by V cos minus IA RA. Okay, minus is for lag, plus is for lead at UPF. Write without doing any mistakes. Just write neatly.